Good afternoon, students. Welcome to the lecture of Operation Research. In the last lecture, we have started understanding the Beale's method. Beale's method is a method for solving a quadratic programming problem given by a mathematician or a statistician, Evelyn Martin Lansdowne Beale. Okay, we have discussed in detail what is the idea behind this Beale's method. This Beale's method does not use a Kuntaker condition, and it involves the partitioning of the variables into basic and non-basic. Also, it uses the results of classical differential calculus. As we have seen in the last lecture, the result we were going to use is if we differentiate a function with respect to x, this gives us the rate of change of f with respect to x. Therefore, if we have the rate of change to be less than 0, therefore it means the function f decreases, greater than 0, increases, equals to 0, means there is no change in the given function. Okay. Therefore, the idea behind this Beale's method is just select arbitrarily any m variables to be the basic variables, remaining will be the non-basic variables. Then try to express the objective function in terms of non-basic variables. Find out its partial derivative at all x and b is equal to 0. If it is greater than 0, then it suggests there is a improvement in that corresponding variable so as to increase the value of our objective function f. If dou f by dou x and b is less than or equals to 0, means there is no improvement in f if we increase the value of the non-basic variable. That is, no need to introduce that corresponding variable to be the basic variables. In order to find out the value of that corresponding variable, which should be increased so that it will give us the change in or increment in the objective function, this can be found with the two steps. First, dou f by dou x and b equal to 0, and find the value of that corresponding non-basic variable without making the present basic variable negative, and finally find out the minimum. Therefore, the algorithm says that first step, convert the problem of minima to maxima if it is not, then introduce slack surplus variables, convert inequality constraint to equations, then choose m basic variables, arbitrarily any variables, m basic variables, then express the objective function in terms of non-basic variable, then evaluate the objective function and evaluate this dou f by dou x and b, that is find out the partial derivative of the objective function with respect to the non-basic variable. Observe the nature of dou f by dou x and b. If all dou f by dou x and b is less than or equals to 0, means no improvement in any non-basic variable will give us the improvement in f. Therefore, whatever is this step, we have to stop the process and the corresponding solution will be optimal solution. Second case is, if at least one partial derivative gives us greater than 0, then choose the corresponding variable to enter in the basis. Let xr be the corresponding non-basic variable for which we get partial derivative is positive. Let xr be the such a variable. Then we will find out the value of xr with the 2 points, dou f by dou x and b equals to 0. Largest value of xr that can be obtained without making the present basic variables negative. We will call the value to be xr star, and then repeat. Go to step number 4 and repeat. We have seen one example on this containing only one constant. Therefore, initially we have converted the constraint inequality to equations. As there is only one constant, means we have to select only one variable to be the basic variable. Therefore, here we have selected x1 to be the basic, remaining two x2 and x3 will be the non-basic variable. Then we have expressed the total objective function in terms of x2 and x3 only. That is replacing the value of x1 in terms of x2 and x3. Then after finding the function in terms of x2 and x3, we have found its derivative of f with respect to x2. We have calculated the value at both the non-basic variable equal to 0. The value gives us 10. Dou f by dou x3, similarly, we have calculated the value is 4. Therefore, both the partial derivatives gives us the positive value. Therefore, among the two, we will select the value which gives us the maximum, right? Because this gives me more improvement in f compared to increment in the variable x3. Therefore, here increase in x2 will give us a better improvement in the objective function. Therefore, we will introduce x2 as the basic variable. Then we will find out the value of x2. The value of x2 can be calculated with the two ways. Dou f by dou x2 equal to 0, which gives us x2 equal to 5 by 6. This is the value of x1, present basic variable. Then if I look at this statement by putting x3 equal to 0, again non-basic, x2 can take maximum value of 1 without making x1 negative. Therefore, among the two, minimum will be 5 by 6 and that will be the value. Now in the next iteration, the basic variable is x2, remaining 2 becomes non-basic. Again we will repeat the same step. Okay. In the last lecture here we have made some confusion. Now I have corrected this. I have substituted the correct value of all the variables and we got the value of dou f by dou x1 as 1 minus 3x1. In the last lecture we faced some problem at this stage actually. Okay, I have corrected it now. I will share you this notes copy. Then later dou f by dou x3 is minus 1 minus x3. Therefore, improvement in x1 gives us the improvement in the objective function f. Therefore, we will find out the value of x1. Again, repeating the same process, we will get the value of x1 as 1 by 3. Therefore, both the values of the variables we got is x1 star is 1 by 3, x2 star is 5 by 6. And we have substituted both the values in the original objective function to get the value of objective function as 25 by 6. Now in today's lecture, we will go for one more example of Beale's method containing two constraints. Okay, if we write the example, maximize zx equal to 10x1 plus 25x2 minus 10x1 square minus x2 square minus 4x1 x2 subject to the constraints x1 plus 2x2 less than or equals to 10, x1 plus x2 less than or equals to 9. Both the variables x1 x2 are non-negative. Let us repeat the process. Objective function is of maxima type, no need to convert it. Constant inequalities we will convert to equations. Step 1 I will call. Introducing what kind of variables are necessary. Hello. Am I audible, students?
Yes, ma'am.
Now we need two slack variables, correct? Na? Okay, let me introduce the slack variable x3 and x4 and we get. What we will get? Let me write the problem again. I'll call timing this is f of x, which is maximize f of x, which is maximize z of x is equal to 10x1 plus 25x2 minus 10x1 square minus x2 square minus 4x1 x2. Subject to the first constraint equality will be x1 plus 2x2 plus x3 equal to 10. Second one will be x1 plus x2 plus x4 equal to 9. Okay. Now what is the job? Next step suggests us select arbitrarily any two variables to be the basic variables. Why we were selecting two? Because we have two constraints. The number of basic variables will be 2. Therefore, here I will write selecting. Let me select original variables. x1, x2 be basic variables. Then x3, x4 becomes non-basic variables. Right now? Now the methodology says that try to express the objective function in terms of non-basic variable. That is, we want to find out the values of x1 and x2 in terms of x3 and x4. In the previous example, it was easy for us as we have only one constraint. Now here we have two constraints. Using these two equalities, we will try to find out the value of x1, x2 in terms of x3 and x4. Time being, let me call this as statement number 1 and statement number 2. What we will do initially, we will try to remove x2 from the two equations, right? What should I do for removing x2 from the two equations? 1 minus equation number 2 into 2. Is that okay?
Yes, ma'am.
divide 2 by 2 and subtract it from 1. What's the equation we were getting? X2 will get cancelled. Will I write in detail? X1 plus 2x2 plus x3 equal to 10 minus 2x1 plus 2x2 plus 2x4 equal to 18. We are doing the subtraction. Okay, this is negative, 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 therefore we remain with minus x1 plus x3 minus 2x4 equal to minus 8. Now let me find out the value of x1. Let us absorb the negative first. It gives me x1 minus x3 plus 2x4 is equal to plus 8. Therefore x1 we will get as 8 plus x3 minus 2x4. Therefore, this is what the value of a basic variable x1 in terms of x3 and x4. Similarly, we will try to remove x1. In order to remove x1, we will just do a subtraction. 1 minus 2 I will call. Okay, therefore what we will get? X1 plus 2x2 plus x3 equal to 10 subtracted with x1 plus x2 plus x4 is equal to 9. We want to do the subtraction. What is the value we have obtained? X1 will get cancelled. We will get x2 plus x3 minus x4 is equal to 1. Therefore, I will get x2 as 1 minus x3 plus x4. Is that okay? We have obtained the value of both the basic variable x1 and x2 in terms of x3 and x4. Thus, we have, let me rewrite the equations. X1 as 8 plus x3 minus 2x4. x2 is equal to 1 minus x3 plus x4. What is the next job then? Try to express the objective function in terms of these non-basic variables. Therefore, we will replace the values of x1 and x2 in the original objective function. Let me go to the next page. Let us write this in terms of x3 and x4. For the sake of our convenience, let me write the objective function here. What is the objective function? 10x1 plus 25x2 minus 10x1 square minus x2 square minus 4x1 x2. Now let us replace x1. What is x1? 1. Let me write x1 also here so that I should not get confused. What for x2? This is 1 minus x3 plus x4. Okay. Now let me substitute the value. 10 x1 is 8 plus x3 minus 2x4 plus 25 x2 is 1 minus x3 plus x4 minus 10 x1 square. 8 plus x3 minus 2x4 bracket square minus x2 square is there. 1 minus x3 plus x4 bracket square. Lastly, minus 4 x1 x2. You have to check all my steps, right? If you feel any confusion, you can just tell me. This is what the objective function we have obtained. Now let us differentiate with respect to x3 and x4. First, let us differentiate with respect to x3. Now differentiate the partially with respect to x3 and x4. Let us differentiate with respect to x3 first. What is dou f by dou x3 giving us? 10 into, here it is 1 plus 25 into the derivative of the second bracket is minus 1 minus, what is the derivative? Minus 10 into 2 times 8 plus x3 minus 2 minus 2 1 minus x3 plus x4 into the derivative of x3. The derivative of x3 is minus 1, therefore let me observe this. Minus 4 times. Now here we have a product of two different brackets. Let us use a product rule. I will keep the first bracket as it is. Derivative of second is minus 1 plus, now I will keep second as it is. What is the derivative of first bracket? 1. Let us complete the bracket. Now we will just simplify this. 10 minus 25 minus 59, right? Then minus 20 times a bracket 8 plus x3 minus 2 x4 plus 2 times 1 minus x3 plus x4. Now we will multiply by minus 4. Minus 4 into minus 1 is there. Therefore, shall I write plus 4, 8 plus x3 minus 2 x4. Again we will multiply by minus 4 into 1 minus x3 plus x4. Is that okay? Let us simplify. Minus 15. Let us multiply by 20. This is minus 160 minus 20x3 plus 40x4. Okay? Multiplying by 2. This is 2 minus 2x3 plus 2x4. Next, 4 is the 32 plus 4x3 minus 8x4. Multiplying by minus 4, this is minus 4 plus 4x3 minus 4x4. Right. Let us check the constant terms first. This is minus 175, 34. Minus 175. This is also there, no? Let me check the constant term. Minus 175. And here it is minus 2 plus 32, 32, 34, 34 minus 4, 30, plus 30, plus 30 minus 175. 145, na? With negative. Okay, everyone has to do the calculations with me. Okay? If I'm going wrong somewhere, you just correct me. Collecting the coefficients of x3 now. Minus 20, minus 2, minus 22, minus 22 plus 4 plus 4, that is plus 8. Yes, minus 22 plus 8. Yes. Students, are you there?
Yes, ma'am.
How much is the value then? Minus 22 plus 8. 14.
Minus 40.
Minus 14 next time. What for x4? Let us check. Minus 40 plus 2, 42. Yes. How much is x4 coefficient?
30.
30 x4. Plus na? 42.
Yes, ma'am.
42 minus 12. This is the value of dou f by dou x3. Now what we were doing? We were finding its value at non-basic variable 0. That is at x3 equal to x4 equals to 0. How much is the value then? This is minus 145. Okay. Now similarly, if it is minus 45, can we take x3 as basic variable?
No, ma'am.
Yes. Now let us go on differentiating with respect to x4. We write the objective function again. Okay. Now let us differentiate with respect to x4. First bracket gives me 10 into minus 2 plus second bracket gives me 25 into 1. Right? Third bracket derivative is 2 times it is, therefore shall I write minus 28 plus x3 minus 2x4 into the derivative is minus 2. Correct? Derivative of this bracket. Then the derivative of this square bracket 2 times 1 minus x3 plus x4 into derivative of x4 is plus 1 again, no change. Minus 1. Let me use a product again. First bracket, let us keep as it is. Derivative of second bracket is 1. Then let me keep second as it is. What's the derivative of first bracket then? Minus 2, right now? Let us simplify. Minus 20 plus 25. Is it 5? Then let us multiply by this minus 2 to 28. This is 40 plus 40 into 8 plus x3 minus 2x4. Next, minus 2 into the bracket as it is. Let us multiply by minus 4 to this bracket. Therefore, this is minus 4. 8 plus x3 minus 2x4. Now this is minus 2 into minus 4. Is it plus 8 into 1 minus x3 plus x4. Okay. Now let us simplify. 5 plus 4 is 32, 320 plus 40 x3 minus 80 x4 minus 2 plus 2x3 minus 2x4 minus 32 minus 4x3 plus 8x4 plus 8 minus 8x3 plus 8x4. Let us collect the coefficients, constant term and coefficients of x3 and x4. Constant term 3, 5 plus 320, 325. Let me select positive terms. 325 plus 8.
299, ma'am.
Good, this is 299. What for x3? 40 plus 2, 42 minus 12 again. Plus 30, no? Plus 30 x3. Correct, no? What for x4? Minus 80 minus 2 minus 82 minus 82 plus 16. Yes, minus 82 plus 16.
Minus 66.
Yeah, it is minus 66 x4. Good. Now we will calculate dou f by dou x4 at non-basic variables 0. How much is the value? It's 299, which is greater than 0. What we have obtained for the previous value, this is less than 0. Na? Let me call it as statement 3 and 4. Okay. Therefore, which variable suggests the improvement in the function here?
X4.
Yes. Thus, increase in X4 gives improvement in f of x, since dou f by dou x4 is greater than 0, right? Therefore, now what's my next step? Number 3 or number 2? Step number 2. Yeah, it's step 2. Step 2, what we will do in this step? We will find the value of x2, sorry, x4. We find the value of x4. Okay, what the two criteria are known to find out the value? Dou f by dou x4 is equal to 0, no doubt, by putting the non-basic variable 0. This is the non-basic, which is the non-basic variable x3, because we want to find out the value of x4. So let me put x3 is equal to 0. What it is giving us? 299 minus, this is 0 now. So this is minus 66 x4. So for the value of x4 we will obtain from the first is 299 minus upon 66. What is the second one? You have to find out the value of x4 without making present basic variable negative. Let me write the basic variables. What is the value of x1 we have? 8 plus x3 minus 2x4. That of the value of x2 is 1 minus x3 plus x4. Okay, look at both the basic variables and you just tell me, no doubt by putting x3 0, what is the value of x4 from the first basic variable without making x1 negative. Yes. Or let us put x3 0. What it is giving us? x1 equal to 8 minus 2x4 and x2 is equals to 1 plus x4. Correct, no? What is the value of x4 without making x1 negative?
4.
Yeah, it is 4. What for the second one? For
Minus 1.
second one, no, we are having x4 positive, non-negative, no?
Yes, ma'am.
All the basic variables are non-negative. Therefore, here, any value of x4, if I take, then x2 will not be negative. If I take any value of x4, non-negative rather, now for any non-negative value of x4, x2 will not become negative. Therefore, the restriction is about x1 only. Therefore, here may I take x4 is equals to 4 without making x1 negative. Right now? There is no disturbance to x2 or any non-negative value of x4, x2 will not be negative. Therefore, two values we have obtained. First, 299 upon 66. Second value is x4. Okay. Then what will be the value of x4 then? How we are selecting?
Minimum of B.
Yes, this is x4 star, which is minimum of 299 upon 66 and 4. Which is the minimum value?
4.
Is 4. Okay. Here we have completed one iteration. Now let us go to step 3. In this step 3, which variable we have introduced in the basis? x4 we have introduced, right now?
Yes, ma'am.
Initially we have x1, x2 in the basis. Okay. We have checked out dou f by dou x3 is less than 0 and dou f by dou x4 is greater than 0. Therefore, this variable x4 we are going to introduce in the basis. Right? Now the question is, which variable should be removed? X4 is introduced, no doubt. Which variable is removed? Arbitrarily one can remove x1 or x2, anything. Okay. Now we will remove x1. Here, therefore, the statement I will write is introduce x4 in the basis and remove x1. One can remove x1 or x2 both. Any variable one can remove. Here we were removing x1. Therefore, which are the basic variable under the consideration now? x2, x4. And what are the non-basic variables then? x1, x3. Is it clear?
Yes, ma'am.
Now what's the next job? Again we have to express the objective function in terms of non-basic variable. But as we have seen, the objective function is expressed in terms of x1 and x2. Therefore x1 is already non-basic. Therefore we have to just replace the value of x2 in terms of x1 and x3. Okay, let me write the constraint equations again. What is the job? What is the job now? In order to write x1, f of x in terms of x1 and x3. Okay, x1 is there already. Therefore, we have to just remove x2 and we'll try to express x2 in terms of x1 and x3. Therefore, which constant equation I should use to express x2 in terms of x1 and x3? Yes. Look at the equations and you can tell me. First equation is used now. x1, x2, x3 key variables we have. But what is the value of x2 we will obtain? 10 minus x1 minus x3 divided by 2. Right now, we have expressed x2 in terms of x1 and x3. Now, the job is to substitute the value in the original objective function, the value of x2 in the original objective function. Now, f of x is written in terms of x1 and x3. Is that okay? Let me write the original objective function again. F of x is equals to 10x1 plus 25 x2 minus 10x1 squared 10x1 squared minus x2 squared minus 4x1 x2. Now let us write f in terms of x1 and x3. We were not disturbing x1. We were replacing x2 in terms of x1 and x3. So 10x1 as it is plus 25 of 10 minus x1 minus x3 Okay, we have to find out the value of x4 also. How to find out the value of x4? Why x4 is essential? While finding the value of x2 without making a present basic variable negative. Na? Now what one has to do, we will put the value of x2 in the second equation. Put x2 in second constant. And just to simplify, we will get the value of x4 as 1 by 2, 8 minus x1 plus x. I forgot actually. Next, this is essential to find out the value of whichever the variable x1 and x3. Next, let me just substitute 25x2 I have substituted minus 10x1 square as it is minus x2 square. x2 is half. Square will be 1 by 4. 1 by 4, 10 minus x1 minus x3 bracket square minus 4. 4 x1 is there, x2 I want to substitute. Shall I write 2 directly? 4 by 2 it is, no? This is 2 x1, 10 minus x1 minus x3. Is that okay? Next step, we'll find out the derivatives in terms of with respect to x1 and x3. First, let me find dou f by dou x1. What's the dou f by dou x1 value? 10 plus 25 by 2 into minus 1 minus 20 x1. 2 times I have to write 2 into 1 by 4. This is minus half. 10 minus x1 minus x3. Derivative of x1 is negative. Let me observe this negative. Minus 2 times. Let us multiply by x1 and then find the derivative. If I multiply by x1, first term is 10x1, derivative will be 10. Second is minus x1 square, derivative will be minus 2x1. Third term is minus x1, x3, derivative will be minus x3. Right now, any difficulty up to this?
No, ma'am.
Let us simplify. 10 minus 25 by 2 is minus 5 by 2. Let me write it initially. 10 minus 2 is minus 5 by 2. Minus 20x1. Let us multiply by half. This is 5 minus here actually as we are getting the constant term negative, let me keep it as 5 minus x1 by 2 minus x3 by 2 minus 20 plus 4x1 plus 2x3. Let me check out the constant terms. What are the constant terms here? Plus 5 minus 20 means this is minus 15. Minus 15 minus 5 by 2 means the constant I'm getting negative. We will no need to simplify because this is going to give us partial derivative negative. So let us calculate directly at x1 equal to x3 equal to 0. Why to waste our time? Okay, I have just calculated the constant. As it is negative, no need to simplify. 5 by 2 minus plus 5 minus 20. This is minus 5 by 2 minus 15. How much is the value? Minus 2 into 15, 30.
Minus 35 by 2.
Good. This is less than 0. As it is less than 0, x1 could not be a basic variable. No, we no need to simplify the value. Let us go for calculating dou f by dou x3. I think we should write f again. And this is the objective function. Let us differentiate with respect to x3 now. Right now, we are differentiating with respect to x1. Now we differentiate with respect to x3. If I am differentiating with respect to x3, first term 0, second 25 by 2 into minus 1 minus 10x1 square 0 minus 1 by 4 into 2 times n minus x1 minus x3 into derivative of x3 is minus 1. Let me make it plus. Right? Then let us multiply by x1 and find the derivative. First term is 10 x1 0 x1 square 0. Only we have the derivative x1 x3, that is minus x1. Let me check the constant terms first.
Minus 15 by 2.
Okay, you calculated directly. Let me write.
Yes, ma'am.
55 by 2, this is 1 by 2, n minus x1 minus x3 plus 2x1, no? Constant is minus 15 by 2, no? No need to
Yes, ma'am.
simplify here. So let me put directly dou f by dou x3 at the point x1 equal to x3 equal to 0. Because these all values are 0, 0. Here it is 25 by 2 plus 10 by 2, that is 5. No? Minus 15 by 2 less than 0. See, anyhow we have obtained both the partial derivatives less than 0. What does it mean? Both the partial derivatives, dou f by dou x1 is less than 0, dou f by dou x3 is less than 0. What it means? You have to stop the process, no? In order to
Yes, ma'am.
continue, we want actually one of the partial derivatives should be positive. Here both the partial derivatives we will obtain is less than 0, right now? Both the partial derivative we obtain is less than 0. Therefore, x1, neither x1 nor x3 can be the basic variables. Let me write the statement here. Hence, both partial derivatives are negative. Hence, neither x1 nor x3 can be introduced to increase f of x or zx we have. Okay, thus the optimal solution is obtained. The optimal solution is what is the optimal solution? X1 still non-basic, therefore what is its value?
0.
0. What for x2 we have calculated in the previous step? 4. Correct na? And what for zx? Zx we have to substitute the values of x1 and x2. Let me write. Zx is 10x1 plus 25x2 minus 10x1 square minus x2 square minus 4x1 x2. What is the value of zx at these two values? These 2 points. x1 0, 25 x2, x2 4 I have to substitute. 25 into 400 minus 4 square 16. This is 0, na? X1 0 I am substituting. These 3 terms are 0. 100 minus 16.
84.
Hence, it is the solution for the given quadratic programming problem by using the Beale's method. If you have any difficulty, you can just tell me. Let me write in short what we have done in the problem. Original function is in terms of two variables x1 and x2. Okay, x3 and x4 we have taken to be the added variable. In first step, we have taken the basic variables as x1 and x2. What we have obtained? Dou f by dou x1, sorry, x3, no? And dou f by dou x3 is less than 0 and dou f by dou x4 is greater than 0. Right now, in the first iteration. Therefore, we have introduced this x4 as the basic variable. Therefore, in the next step, introducing x4 in the basis, We have removed x2, therefore the new basic variables are x2 and x4. Therefore the non-basic variables are x1 and x3. Here the non-basic variables are x3 and x4, right? Now, as the non-basic variables are x1 and x3, we have calculated dou f by dou x1, which we found less than 0. Similarly, dou f by dou x3 we have found less than 0. Therefore, no further improvement in x1 and x3 will be suggested. Therefore, whatever the basic variables are the final. In this step, we have calculated the value of x4 as x2 as 4. Na? For the final solution, we have written x2 non-basic 0, x2 is 4, and at this point we have calculated the value of z as 84. Or partial derivatives we have calculated. What is the small hint here? While doing the simplification like this, at this step, finding the coefficients of x, you first check the constant term. If the constant is positive, you have to write the in detailed value. Otherwise, you directly put x1, x3, 0 and calculate. Let me show you in the first step. In the first step also, here there is no need to make this simplification. No? You first check the constant. If the constant is negative, no need to find out this simplified value. You can directly get it. But here, if the constant is positive, you have to find the simplified value because this value is essential for finding the value of x4. Is that okay?
Yes, ma'am.
I think I have missed one step. x4 we have calculated, no? Oh, sorry. x4 we have calculated as 2, not x2. What's the problem? Here we have forgot to calculate x2. Right now? Sorry. x1, x3 cannot be introduced, but one can find out the value of that basic variable x2. What is the value of this basic variable? x2 I have to calculate. x1, x3 putting x1, x3 0. x2 star is not 4. Is half 10 minus, what's the value? 10 minus x1 minus x3. Let us put both the values basic variable 0. Therefore, the value of x2 is 5. Sorry. Now check value of z. x2 5 I substitute. Here I have written x4 4. What is zx now? Sorry, for x2 equal to 5. 25 into 5 minus
100, ma'am.
I square. It is 100 now. Yeah. And here 5. So x4 I have calculated. No, I thought I have calculated x2. Yes. Is there any difficulty in the problem now? Yes. Somewhat lengthy it is, but simple method. Okay, let me repeat. x1, x2 initially basic variable. x3, x4 are non-basic. We have found the partial derivative. For dou f by dou x4, we have obtained a positive value. Then we have calculated x4. Then we have taken x2, x4 basic. But both the partial derivatives are negative. Therefore, neither x1 nor x3 will be non-basic. It remains to calculate the value of x2. The value of x2 is 10 minus half 10 minus x1 minus x3, but x1, x2 are already 0. Therefore, x2 takes the value 5. And at the point x1 0, x2 5, we have calculated the value of objective function as well. Okay, this is what the problem. If you have any difficulty with the example, you can ask. With this, actually, we have completed our third unit also. We have completed our third unit. Let me give you some examples for homework. Try for both the examples by solving both of them. Okay, let me stop for today. If you have the difficulty, you can unmute yourself and ask. In the next lecture, we will start the new unit called as game theory. Thank you for being with me for today's lecture. Thank you.